Hey friends, this is Miss Regine from SOAR Educational Services. Today we are going to look at how to analyze exponential functions, specifically how to find the domain, range, and end behavior, which a lot of students struggle with. So I have an equation written here, and I actually already created a little XY table for you. So everything here is on the first quadrant. So when X is 0, Y is 4, and you can just do this by making for the next one you'll see, just make an XY table and plug in numbers. When X is 1, Y is 1. When X is 2, Y is 1/4. And you can create more values, but I pretty much have an idea that it's going to look like this. First of all, I don't see a number after right here. Like there is commonly a number like plus something or minus something. I don't see anything here. So I know that my asymptote for my exponential function is at 0. So let me draw this so that I know my line is not going to go past 0. My asymptote is at 0. This is a decay. It's a decay because it's a fraction. So it just means that whatever it is going down 1/4 of the value each time. So as you can see, at first we started at 4. Now we lost 1/4 of our value and we're at 1. And then we lost 1/4 of that, we lost 3/4 of it and kept 1/4. Sorry, and now we're at 1/4. So the 1/4 is actually what you're keeping, but that means you're losing 3/4 of it. So that's my graph. Now, if they want to know the domain is all real numbers, negative infinity, positive infinity. We can plug in anything into this and it will work. There are no restriction for this. Now, range though is different. Range, you can say that, you can write it two ways. You can say the range is your y. So if I'm looking at this graph, I just said this graph cannot go below that 0. So it's going to be y is greater than 0. It's not even going to equal 0. It can't even equal 0. It's never going to touch that 0. So y is greater than 0. I can write it as 0 to positive infinity. It can go as high as it wants. Now, in behavior, let's look over here. Right here. Now, you can extend this graph a little bit more. And I did say that x can go in all directions. It's all the way from negative infinity. So for in behavior, as x reaches negative infinity, because it can do that. X can go to negative infinity. Y is going to positive infinity. Y is going up. You can see this graph is going up. And then here, as on this side, as x reaches positive infinity, because they get no restriction on our x, so x can go to positive infinity, y is reaching 0. But y will not cross that 0. It's just getting ever closer to 0, but it's not going to cross. All right, so here's another one. I think it's y. So this one's a little more complicated. And you see, it does have a number here that tells me where my asymptote is. I've already created, I just used 2 point, -1. Just if you plug in -1, and I got -8, and then 0, that's always a good one to use. And I got -5. Okay, drawing this, I can see that it's going to be on my negative side a lot. So when x is 0, y is -5. When x is -1, y is -8. 6, 7, 8. So my graph, and my asymptote is at -9. Oh, okay. My asymptote is at -9. I know that because of this value right here. So let me draw my asymptote line. This is a growth. So I need to make sure I draw it as a growth. It's not a reflection. It's not going upside down. It is a growth. It has a growth factor of 4. So growth, exponential function at our growth goes this way. So again, I could have tried some other numbers to plug in here, but basically it looks like this. So I know it's a growth, so it has to go that way. It should not be upside down or anything like that because there's no negative sign in front of it for it to be a reflection. All right, domain for this particular graph, again, it's negative infinity to positive infinity. Range, I established that early on that this is my asymptote. It's not going to get lower than this. So y is greater than negative 9. I can say negative 9 to positive infinity. And behavior. When this graph is in a negative infinity, like you see negative 1, negative 2, negative 3, negative 4, negative 5. So as x reaches negative infinity, y reaches negative 9. It's getting ever so close to negative 9, but never touching. And on the other side, as x reaches positive infinity, so we have 1, 2, 3, and it keeps going, y also reaches positive infinity. All right, so that's all for this one. Again, we reviewed how to create graphs for exponential function and then use that to analyze different characteristics of the graph. Hope this was helpful. Remember to like and subscribe. I'll see you next time. Bye.